Hello viewers, in this video let me talk about perspectives. First of all, I would like to explain the concept of perspectives. Then we will move on to categorization of perspectives. Then we will see the methods to generate perspectives in Autocad. So let us see what exactly is a perspective. See, perspective is a realistic view in which the objects which are close to us tend to appear bigger and the objects which are away from us tend to appear smaller. Because they are very realistic, they are used in architectural presentations. Now, in this image, you can see that the objects which are close to us, these pillars are bigger, and these pillars which are away from us are smaller. So it's a realistic view. So this is the concept. Now let us see how are the perspectives categorized. See, the perspectives are categorized based on the number of vanishing points. Let us see what exactly is a vanishing point is. See, when you draw lines along the edges of this image and when you produce these lines, they'll tend to converge or meet at an imaginary location. And this imaginary point is called vanishing points. Depending on the number of vanishing points, the perspectives are classified or categorized as single point perspective or linear perspective, then 2-point perspective or angular perspective, then 3-point perspective or oblique perspective. Now let us study each perspectives in detail. So as in a single point perspective, as the image shows, you will have only a single vanishing point. Now let us see how will you generate this single point perspective using AutoCAD software. If you want to generate a single point perspective in AutoCAD, you have to keep the target and the camera at the same height, and the line of sight should be either horizontal or vertical after you give the dynamic viewing command. And this perspective is preferred for interior views. Now when I illustrate it, it will be more clear. Now let me go back to the 3D model of the kitchen which you have done earlier. Now I would like to generate an elevation. So first of all, I will introduce the simplest and the easiest method to generate perspective in AutoCAD. Now I want to generate a front elevation or a south side elevation. So that you can either give a viewpoint 0, -1, 0 for a front elevation, or else you can just click on the south because it's a south side elevation to get that front elevation. Now you have to go to orbit command and just right click and you will see two options in the pop-up menu. Here you have a parallel projection or a perspective projection. Presently the projection is a parallel projection, so just click on the perspective to get a perspective. So this is the simplest and the easiest method, but we have some limitation in this method. So here we can't control certain parameters like the position of the camera, the focal length of the camera, and the type of perspective, etc. So this is where we have to make use of a very useful and versatile command in AutoCAD, and this command is called dynamic viewing or dview. So just go to dview command. You have to give dview command in AutoCAD. So I'll give dview and it'll ask you to select the objects. So you can go for selective visualization. You need to select only those objects which are to be visualized. I've selected it. Now you have to go to the points option here. So I have a points option. So I'll type PO. This points option will let you specify the target point and camera point. Now what is target? A target is a point towards which you look at, and the camera is a point from which you look at. So I'm going to define a target point. If I simply make a click here, this point will be taken on the XY plane. So in fact, I want the target to be elevated from the XY plane or from the floor level through a certain height of say 150 units. So I will define the target using point filters. So I'll go to shift right click, go to point filters, and I'll select .xy off and I'll pick a point over here. So only the X and Y coordinate of that point is selected. Now it'll ask you for Z. Z I'll give as 150 units. So it has taken the target. So I'll give it once more. I'll give .xy off. I'll pick a point over here. then I am asked to give Z. I'll give Z coordinate of 150 units. So the target is defined. Now you have to turn the ortho mode on because I want to keep the line of sight as vertical, or it can also be horizontal to get a single point perspective. So I'll specify my target, the camera. Now the camera point, I'll use again point filters to define. I'll go to point filters and I'll select .xy off. I'll pick a point over here. Then it'll ask me for Z coordinate. I'll give Z coordinate as the same height, 150 units. So you have defined a line of sight. But still I am in the orthogonal view. So if you want to get back to perspective, just go to distance option, type D here. Now it will show you the current distance separating the target and the camera. You can either just give an enter to select this distance, or you can give a different value if you want to vary the distance. So I'll just give an enter. So I just give hide. Now you have got a perspective view here. So now you have so many options. You can either change the distance of the perspective or the camera if you want, or you can change the focal length of the camera. Now I would like to change the distance slightly. So I'll go to distance option again, and it will show you the current distance as 878. I'll give a higher value. Let it be say 1000 units. So the camera is moved slightly backwards. Or else if you want, you can change the focal length of the camera by using the zoom option. So type Z for zoom. Now it will show you the current focal length of the camera as 50 mm because that is a default focal length. I would like to bring it down to say 35 mm. You know that when you reduce the focal length of the camera, the field of view of the camera will get widened. So it will become a wide angle view. Or else you can also go for zoom option and you can give a higher value for focal length and you will get a zoom view, or it will be having the same effect of putting up a zoom lens in the camera. So this is how you generate a single point perspective. Now you can see that we have only a single vanishing point. So I will explain the method once more. In a single point perspective, you have to go to plan view. Then you give dview command and you select the objects to be visualized. Then you select the target and the camera points using point filters in such a way that the line of sight will be either horizontal or vertical. Then you go to distance option and give an enter to get a perspective. So this is how you make a single point perspective. Now let us see a 2-point perspective. So how do you get 2-point perspective? See, 2-point perspectives are those perspectives which will have two vanishing points. When you look at this figure, you can see that you have got two vanishing points. You have a vanishing point in the left side as well as in the right side. So look at this figure. Here, this image is a 2-point perspective. When you extend, when you draw lines along these edges, and when you produce these lines, you will have a vanishing points on the left side. And when you draw lines from these edges, you will have a vanishing point on the right side. So you can say this is a 2-point perspective. Now let us see the method to generate this perspective in Autocad. If you want to generate a 2-point perspective, keep the target and the camera at the same height, just as we have done for single point. But here, the line of sight should be inclined. It should be inclined. Now, such perspectives are preferred in exterior eye-level views and ANSI views. Now, let us see. Let us take a model and we'll try to generate a 2-point perspective in this model. So, in this model, I'll give, say, dview command, and I'll select the objects to be visualized. And I'll go to points option and I'll select the target and camera points just as we have done before using point filters. So I'll go to shift right click, I'll go to point filters and I'll select .xy off. I'll pick a point over here and I'll give Z as 250 units and it'll ask me for the camera. I'll again go to point filters and I'll select .xy off. I'll pick a point over here and I'll give the same height for the camera. You can see that the line of sight is inclined. Okay, now I'll just give an enter. Now I'll go to distance option and just give an enter to get a perspective view. So this is a perspective, just give hide. See, this is a 2-point perspective because when you draw lines from these edges, you will have vanishing points on the right side, and when you draw lines along these edges, you will have another vanishing point on the left side, and you cannot find a third vanishing point because these lines are parallel to each other, so they'll meet at infinity. Hence, there are two vanishing points. So this is how you generate a 2-point perspective. So in order to get a 2-point perspective, your camera and target should be at the same height and the line of sight should be horizontal. Sorry, it should be inclined. it should be inclined. Now, if you have any clarifications related with point filters in defining these points, just refer my previous video on point filters. Now let us see 3-point perspective. Say in a 3-point perspective, you will have 3 vanishing points. As this figure shows, you will have vanishing points over here, and then you have a second vanishing point on the right side, and you have the third vanishing point underneath. So you have 3 vanishing points. Now I would like to show you the comparison between the single 2-point and 3-point perspectives. Here this figure is a 2-point perspective because you can see one vanishing point on the left side and right side, and there is no third vanishing point. Whereas in here you can find a third vanishing point because when you extend these edges, you can find a vanishing point above. So let us see how to generate a 3-point perspective using Autocad software. So in a 3-point perspective, if you want to generate a 3-point perspective, you have to keep the target and the camera at different heights, and the line of sight should be inclined. So there are 2 conditions. The target and the camera should be at 2 elevations, 2 heights, and the line of sight should be inclined. Now such perspectives are preferred in bird's eye views and aerial views in architectural presentations. Now let me open another file to demonstrate this. So I'll go to dview command and I'll select the objects, and I'll go to points option. When I'm asked to specify the target point, I'll use point filters. I'll type .xy off. I'll pick a point over here, and I'll give a height of say 100 units for a Z. And when I'm asked to give this camera, I'll specify .xy off. I'll pick a point over here, and I'll give a height of the camera as a 15,000 units. Now you can see that the target and the camera at different elevations, and I'll go to distance option and just give an enter to generate a perspective. Now I would like to increase the distance, so I'll go to distance again, and I'll give a higher value. Instead of 18,020, which is the present distance, I'll give a distance of say 25,000 units. Now the camera is still moved backwards, and you can orbit this view. If you want, you can orbit this view to get a eye level view or an answer eye view. Okay, you have a lot of flexibility in here, and I'll just hide this, and you can see that you have one vanishing point over here, one vanishing point here, because when you draw lines along these edges, you can have a vanishing point here, and when you draw lines along these edges, you will have vanishing point on the right side, and these lines are no longer vertical, they are inclined. So when you produce these edges and when you draw lines, you can find a third vanishing point underneath. So this is a typical example for a 3-point perspective, and this is how you make a 3-point perspective. So how do you make it? In a 3-point perspective, that camera and the target should be at different elevations, at different heights, and the line of sight should be inclined. So it is very easy to generate perspectives using Autocad software, and you have a lot of flexibility in controlling the position of the camera and certain parameters such as the focal length of the camera and the type of view, the type of perspective, etc. So this is all about perspectives. You can try out this using Autocad software. All the best. Thank you.